Hi everyone, today we are talking about how we multiply and divide our rational numbers. And again, rational numbers, as a reminder, are numbers that we can express or rewrite as fractions or ratios of each other. All right, let's talk about the rules for multiplying fractions. When you're multiplying fractions, you can either multiply across and then reduce, or you can first cross reduce and then multiply across. It really doesn't matter. And it really depends on your preference. And if you're dealing with a whole number, you may need to add a 1 underneath it to help you visualize the numerator and the denominator. So be sure that you have this written down in your notebook. And here's an example, 6 times 1/2. So we'll go through both methods. So multiplying across and then reduce first. So to multiply across, I'm going to change my whole number, the 6, into a ratio or a fraction by adding a 1 underneath, because this is just saying 6 ones. Multiply across, so 6 times 1 is 6, 2 times 1 is 2. And then I reduce. 6 divided by 2 is 3. Or I could cross reduce first. So again, 6 over 1, because it's a whole number and we're changing it into a fraction, times 1/2. So cross reducing, you're just looking across at your numbers. Well, 1 and 1 can't be reduced anymore, but 6 and 2 both can be divided by 2. So if I divide it by 2, I get 3 on top, and this becomes 1 on the bottom, so it really doesn't do anything. And then I multiply across. So again, now my top numbers become 3 and 1, and my bottom numbers are 1 and 1. So multiplying across, 3 times 1 is 3, and 1 times 1 is 1. We don't really need to write the 1 on the bottom, so it's a whole number 3. Okay? And sometimes people like to not write all the division. They'll just simply reduce, and then it'll look something like this so that it's less busy. 2 divided by 2 is 1. 6 divided by 2 is 3. But you do have to kind of know that you're dividing top and bottom by 2. And then they multiply across by looking at the 3 and the 1. So 3 times 1 is 3, and 1 times 1 is 1, so it's just a 3. Okay, that's multiplying fractions. Multiply across and then reduce, or cross reduce first and then multiply across. So that's the important thing about reducing, is that you're reducing across. Okay, let's look at our division, dividing fractions. So dividing fractions, you probably remember that you can keep, change, flip. You'll keep the first number the same, change the sign to multiply instead of divide, and then flip the second number. And when flipping the number, you're going to be using the reciprocal or multiplicative inverse. And again, you may need to add a 1 under a whole number. But the key vocabulary here is the reciprocal. So let's take a look at this example. -8 divided by 2, which could also be written with a fraction bar. So the fraction bar also tells you divide. So if you just see a fraction bar, it's really meaning division, because remember, the division sign is kind of like having one number on top and one number on the bottom with the bar. So if you see that, that just means division. So we have -8 divided by 2. So again, we're going to keep the first number the same. It's a whole number, so we're going to add 1 on the bottom, change the sign from a division to a multiplication, and then we're going to flip the second number. So this 2 really has a 1 on the bottom, so we'll flip it so that the 1 is on top now and the 2 is on the bottom. Then it becomes a multiplication problem. I can either multiply across and then reduce, or I can cross reduce. Let's practice cross reducing. 2 and 8 both go in, are divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So now across on the top, I have -4, don't forget the negative, times 1. -4 times 1 is -4. And then 1 times 1 on the bottom is just 1, so we don't need to write that. The answer is -4. Now you're probably thinking to yourself, why does keep, change, flip work? Like, how can we explain that, right? So what we can do is draw 8 holes. 1, 2, I know it's a negative, but we're going to pretend like it's a positive for the purpose of this. 3, 4, 5, 6, 7, and 8. Okay, and then these 8 holes are all shaded in because we're talking about all of them. We're not talking about a fraction of them, right? And then we need to divide them into two equal groups, okay? So if we want to divide them into 2 equal groups, think to yourself, how can I divide them into 2 equal groups? Well, one way we can divide them into 2 equal groups is just split them in half. So you see where the half is coming from now? Whoops, that last one was not very equal. We're just splitting them in half. Each of these in half. Okay, so that's why -8 divided by 2 is really the same as -8 times a half, because we're finding a half of it. So then these two come together to make one whole, right? Because they're halves. These two come together to make one whole. These two come together to make one whole. And these two come together to make one whole. So half of 8 would be 1, 2, 3, 4. So that's why dividing by 2 is the same as finding a half. So it's the reverse of it, the inverse. All right, let's work on some examples. Here's the first one from your book, example 17. Evaluate the following. Evaluate just means to solve, okay? So we're just solving for the answer. Go ahead and pause your video and try these on your own first. All right, here, let's try A. This says -9 over -9. Remember what we said before is that it's really a division problem. This is really -9 divided by -9. I'm going to put parentheses there so that they follow. Okay, so it's a normal division problem, even though they wrote it as a ratio or a fraction. 9 divided by 9 is 1. Remember, for our integers, a negative divided by a negative is a positive, so it's just an ordinary 1. Part B. -9 over 1/9. Remember, this is just a division problem, so this is really -9 divided by 1/9. Okay, so we're going to keep, we're going to change, and we're going to flip. Oh, hey, look at that. Ended up being -9 times 9. 9 times 9 is 81. Negative times positive is negative. So it's -81. So even though they wrote it all confusing looking, you're just remembering that's a division problem and rewrite it as that. Part C, 1/9 over -9. Remember, that's just division. 1/9 divided by -9. And it's a division problem, so we're going to keep, change, and still negative. Flip though, because there was a 1 on the bottom, so now the 1's going to go on top. All right, now this is a multiplication problem. I can multiply across, there's nothing to reduce anyways. 1 times 1 is 1. 9 times 9 is 81. Now there's a positive times a negative. Positive times negative is negative. So our answer is -181. All right, one more example. This one is multiplication. Find the value of -2 2/5 times 3/4. giving your answer in its simplest form. Go ahead and pause the video and try it on your own first. All right, we have multiplication here. Don't need a common denominator for multiplication because we're just multiplying across. However, 1 is a mixed number, so let's change it to an improper fraction so that we have just a numerator and a denominator, because when we have this whole number, we can't exactly multiply across. So remember, our shortcut was to multiply the whole number by the denominator, and don't forget it's negative. 5 times 2 is 10, plus that remainder of 2 on the top. So 5 times 2 is 10, plus the 2 is 12. So we have 12 fifths, okay? Because 2 and 2 fifths is just 2, plus 1, 2, 3, 4, 2 of the fifths, this one and this one. So we have, whoops, let me redo that. Two and 2 fifths. So we have 2, all shaded in, 1, 2, 3, 4, 1, 2, 3, 4. All of these are shaded in because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the holes, 11, 12. So that's how I get the 12 fifths. 12 fifths are shaded in, okay? And that's why we use a shortcut. It's better than drawing it all out. Okay, and then the second number stays the same, 3/4, and then we got ourselves a numerator and denominator we can multiply across. Unless you see something you can reduce. I see something. 12 and 4 can both be reduced and are divisible by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So we have 3 times 3 on top, which is 9, and don't forget that negative, over 5 times 1, which is 5. So it's negative 9 fifths, because a negative times a positive, negative times positive is negative. So that's negative 9 fifths. All right, here's one last challenging one for you. Find the value of negative 2/3 divided by the quantity, because we see some brackets there, of 1/2 minus negative 1/3. Go ahead and pause the video and see if you can try it on your own first. All right, so I notice that there's a negative and a negative right next to each other, and that's going to become a positive according to my rules. So I want to go ahead and simplify that first. So I'm going to copy everything down that I haven't touched. Negative 2/3 stays in the parentheses so they stick together. Divided by, let's put a parentheses there, 1/2. Now this becomes plus, because negative and negative is positive, 1/3. Okay, and just like that, I get rid of one of my brackets, because this parentheses here was just to protect this negative from everything else, right? But now that it's negative and negative is positive, I don't really need the parentheses because there's no negative in front of the 1/3. So I got rid of one of the sets of parentheses. Still have this one though. 1/2 plus 1/3 is still inside the parentheses. And if you remember, according to PEMDAS, I need to do the parentheses first, everything inside the parentheses. So this is going to be my first step, okay? And if you haven't realized by now, I love to get rid of the negative and negative together first before I do anything, because it's just going to make my problem a little easier. Okay, so let's deal with the parentheses first. Let me get rid of some of these lines. All right, so that means this stuff I don't touch. The division sign I don't touch. I'm just going to do the 1/2 plus 1/3. Uh-oh, it's addition. So if you remember addition and subtraction, we have to have common denominators. I need to find the least common multiple between 2 and 3. Well, 2 and 3 can both get to 6 by multiplying by 2, top and bottom, because it needs to be equivalent for the 3. The one with the 3 as a denominator. 3 times 2 is 6. And the one with 2 as a denominator, I can multiply by 3 to get to 6. Top and bottom to keep it equivalent. All right, so then I'm going to get a 6 as a denominator. So it's going to divide by 3 times 1, which is 3. 3 times 2, which is 6. 3 6 is half, just like that, so I know it's correct. Plus, don't forget my parentheses, 2 times 1 is 2 on the top, 3 times 2 is 6. So now I have the same denominator, and of course my numerators changed. They can't still be 1 because I have to multiply top and bottom by the same thing. Okay, and then now I can do that math. Everything I didn't touch stays the same. 3 6 plus 2 6 is 5 6. And then it moves out of that parentheses because I don't need that anymore. And now I just have a division problem left. Remember division, I keep, change, and a flip. So let's see, can we cross reduce over here? Yes, 3 and 6. 3 divided by 3 is 1. 6 divided by 3 is 2. So on the top now, I have negative 2 and 2, which is 4, and 1 times 5, which is 5. Negative times positive. Negative times positive is negative. So my answer is negative 4/5. It's already simplified, so I'm done.